right, so a histogram question here, talking about motorists and the speed as they enter a tunnel between 1 a.m. and 2 a.m. So speed limit on entering the tunnel is 70 miles per hour. How many motorists were exceeding this on the tunnel, on entering the tunnel? So how many people were going faster than 70 miles per hour? Well, 70 is there, so we're interested in these bars here that go beyond 70, okay? And remember, to get how many, okay, we just need the frequency, okay? And you don't get that from here, because this is frequency density. You get the frequency by working out the area. So there's 70, we're going to work from there. So the area of this there, that's going to be 10 times 4, okay? The area of the next bar, that's going to be 10 across times 2. Next bar, well, there's nothing there. And then this one then, that's going to be 10 times, now I think those are 3 little squares, so it'll be 0.6. Okay, so working out these areas, that's going to be 40, that's going to be 20, that's 10 times 0.6, well that's 6 tenths, so that's going to be 6. Add that, you get 66. Okay. Part B then says, in order to compare the speeds of motorists between 1 a.m. and 2 a.m. with other 1 hour periods, it is decided to group the data in equal intervals of width 30 miles per hour starting at 0. Construct a histogram to show this. Well, if we look at what we've got here, okay, we've got between here 0 and 30 already done for us. So we've already got our frequency density there, okay, done for us. So between 0 and 30 miles per hour, our frequency density is going to equal 0.5. Okay, then we need to go between 30 and 60. Okay, now for that we need to work out what this frequency density is going to be for our bar between 30 and 60. So for that then, we need the areas of these. Now the area of that there is going to be 10 times 2 is 20. Area of that 10 times 4 is 40. Area of this then 10 times 9 is 90. So add them together, that would be 60, that would be 150. So the frequency is 150, but to get the frequency density I need to divide the frequency by the class width, and the class width here is 30, so that comes out as 5. And then 60 and 90, well that area there, 10 times 6 is 60, that's 10 times 4 is 40, 10 times 2 is 20. So between 60 and 90 you've got 120, so frequency density will be 120, divide by the class width, which is 30, so you get 4, and then between 90 and 120 frequency density then would be the total frequency. So you've got, well there's nothing there, and this there I think we worked out earlier to just be 6, so it'll be 6 then in this block here, 6 then divide by 30, okay. Now 6 divided by 30, 30 the class width, that's 1/5, isn't it? 1/5, so that's 0.2, okay. So then when we come to our frequency density down here, we need to label the axes. Okay, we need to label this axis as well. I think it was speed, wasn't it, miles per hour. So the speeds then going up just like before. So we had, what do we have? That they were going 20 there, 40, 60, 80, 100, 120. Frequency density needs to go all the way up to 5, right? So it makes sense there to do it like that. 1, 2, 3, 4, 5. So we draw a bar. The first bar between 0 and 30 is going to be 0.5. Second bar between 30 and 60 is going to be 5. So bars are of equal width. Next bar, 120 to 30 is going to be 4. And, sorry, from 60 to 90 is going to be 4. And the final bar then is going to be 0.2. Now 0.2 is going to be all the way down here. It's going to be quite small. And then it says, given that the speed limit is 70, which of the two histograms is the more appropriate for display of the data? Now, in terms of what's more appropriate, well, I think the first one was more appropriate, wasn't it? Because it was easy for me to figure out how many were exceeding 70, because I could work out the areas. Here it's a bit more challenging, because 70 is there. So the first one we'd say, okay, first one, because it is easier to determine, okay, who sticks to the speed limit and who exceeds.